Ross Pink Electronic Innovations, demonstrating a test setup that we have on a piece of equipment that's malfunctioning in a factory at present. It consists of two Kinway AC servo drives. This one is the master, this one is the slave. For each of these we need to have two motors. Conveniently they were available. This is a permanent magnet AC servo drive, and this is the same sort of motor. In order for a drive to drive this motor, it needs to have information about the position of the rotor. So we need a resolver which gives you that absolute information. Luckily we were able to get one of these connectors, these cables from the actual machine, but the other one we couldn't pull through. So we had to make up another cable for that. So we have to also simulate things like the on-off button, that's fair enough, the run command, the pressure set point. We have to simulate, we're just doing that manually at the moment, the pressure feedback, and this is the flow set point. So if I turn it on using our isolation transformer, which gives us a convenient way to turn it on, and also certain limits on the power, which makes for less damaging situation if something goes wrong. The units will power up. Error 15. Okay, so I look up error 15 and I find, yes, error 15 is to do with the pressure transducer being faulty, which I know, I've tried this before. If the pressure seen is seen to be too high at the start, it thinks that's a major problem. So let's try again. Okay, no error now. So I can ask for a bit of pressure set point. I can tell it to start. At the start, there's a little bit of a bit of a thump to start. But if you look at these motors here, both the master and the slave are running. If you ask for more flow, they both run faster. And if it make it look like the pressure is too much, naturally the motors have to slow down. Okay, so at this stage I won't take the time up to show the fault occurring, but I can cause the fault by putting heat from this heat gun into this sort of an area. Now it appeared that the fault might be one of these two ICs that we just see here. So these two ICs, I'll just turn it off so I can touch that without danger. Power lead's still on, now it's off. So this little chip here is an opto-isolator, and it provides isolated feedback about the voltage of the supply that the controller is controlling. This switch mode chip, fairly standard one, uses this transistor and is able to produce that voltage. It appeared to be a fault at this point, so I brought wires out to be able to look at that and recorded when the fault occurs. This bottom one is the 5-volt supply, and we see that, it starts to go up. This is in the circuitry that goes to the opto-isolator, and the opto-isolator is telling it, is the voltage too high or is it too low? And here, abruptly, it says that it's too low, and naturally the circuit increases the voltage. So that is the fault, and it must be somewhere in the circuitry here. So the next stage with this is we'll have to trace out that part of the circuitry. I'll take that board off, turn it over, take pictures, and identify exactly where the fault is. Thank you.